So we just finished number 1, creating and then solving a set of linear equations to find two numbers, 63 and 24, that fit the criteria up here. We're going to look at a problem that's a little bit more difficult. If you can do this one, I'm pretty happy. We're going to look at one that's a little more difficult here. A 2-digit number is equal to 7 times the sum of its digits. Whew, let's stop and think about that a minute. A 2-digit number. We don't know what the number is. Let's call it x. All right. X is a 2-digit number. How would I represent a 2-digit number? For instance, let's look at the number, I don't know, 35. That has 2 digits. In fact, the only 2-digit numbers we know of are the numbers 10 through 99. There aren't any other 2-digit numbers. So we know it has to be somewhere between 10 and 99. How would I represent that with variables, though? How would I represent this first digit? We have to think about what place value those digits are in. This first digit is in the tens place. So to represent that first digit, I have to use 10 times whatever that digit is, 10a. This is in the ones place, so I'm going to use, let's use b as the ones place. So 30 plus 5 is 35. 10a plus b is my 2-digit number. It's a little more complex, isn't it? All right, and this 2-digit number is equal to, and give us our equals piece, 7 times the sum of its digits. 7 times the sum of its digits. Now, the digit itself is just a and b. So I have a 2-digit number is equal to 7 times the sum of its digits. This is the number, this is the sum of its digits, and I'm multiplying it by 7. Ugh, that's a little harder, isn't it? You have to understand a lot of things here. The number formed by reversing its digits is less than the original number by 18. So if I take this number and reverse the digits, I will get 10b plus a. And it's less than, it is less than, so I'm going to have to write is equal to less than the original number by 18. Well, there's the original number, and less than that by 18. So the number formed by reversing its digits is 18 less than the original number. Those are some pretty complex equations. Now, we've taught ourselves how we can simplify these things, though. All right, I'm going to simplify this first one. I know that I can do this. 10a plus b equals, and use distribution. Distribution allows me to multiply that 7 by both things inside the parentheses. Simplifying this more, I have an A, and I have 10 A's, I have a B, I have 7 A's and 7 B's. There's a lot of different things that I need to simplify here. I need to get all the A's together and all the B's together. Well, if I subtract 7A from here and subtract 7B from here, that will give me, I have to do it to both sides, 10A minus 7a is 3a. b minus 7b is minus 6b. And that equals 0. That's a little easier to look at, isn't it? Now, because I've formed, this is an idea I want you to understand. Because I have formed these two equations, and I'm confident that they are the description algebraically of what's up here, I don't have to hold on to this confusing mass of words and thought. I can just use now these formulas to see if I can solve for A or B. I can forget about this and just solve these linear equations for A or B without trying to think of a whole bunch of different numbers and guessing and checking. Okay? That's what the beauty is of using algebraic and linear equations. Let's look at this second one and simplify it. I have 10b plus a equals 10a plus b minus 18. I'm going to do the same thing. I'm going to subtract 10b from both sides and subtract a from both sides. Oops, minus a and minus 10b. And that will give me 0 equals 10a minus a, 9a minus 9b minus 18. If I add 18 to both sides, that gives me 18 equals 9a minus 9b. Now I have two somewhat simple equations that I can work with. Now I tell myself, gosh, I don't have enough room here, so I might need some scratch paper. So I grab some scratch paper. Don't have room on the other side either. Mr. Rob, can I have some scratch paper? Since this is a Think Aloud. So Mr. Rob comes over, gives you a sheet of scratch paper. I'm going to kind of leave that right there and refer back to it every once in a while. But we know that all this work that I just did brought me about to just these two equations. And I know if I just use these two equations and solve for a and b, I don't have to worry about anything else. So let's just write those down right here. 3a minus 6b equals 0. And 9a minus 9b equals 18. Okay? Now I can kind of forget about what's on that other page for a little while because I know that I'm just working with these two equations. It's that simple. Okay, let's look at that. I look at this carefully and I realize that I don't like substitution very much. To solve for m, I'm going to have to divide by a bunch of things and all that kind of stuff. And so I've decided that what I want to do is multiply this top equation by a negative 3. Multiplying this top equation by a negative 3 will make this 3a a negative 9a. And that's exactly the opposite of a positive 9a. And if I can do that and then add the two equations together, it will eliminate the a. So once again, we're going to use elimination to solve this. Let's do that. I'm going to multiply this by a negative 3. Negative 3 times 3a is a negative 9a. Negative 3 times a negative 6b is a positive 18b. And a negative 3 times 0 is 0. So now I've effectively replaced this equation right here with this one down here. And now I'm just simply going to add these two equations together. What's 9a plus a negative 9a? 0, isn't it? Those just cancel each other out. They're gone. A negative 9b plus 18b is the same thing as 18b minus 9b, which is 9b. And 18 plus 0 is 18. Okay with that? Now, that would mean if 9b's is 18, then 1b would have to be 18, 1/9 of 18, or 18 divided by 9. b equals 2. Cool. Well, now that I have b, I can go into one of these equations and find a. Let's just use this one. 3a minus 6 times b, and b is 2, equals 0. So I know that 3a minus 12 equals 0. I want to get a by itself, so I'm going to add 12 to both sides first. And I get 3a equals 12. If I divide both sides of this by 3, I get a equals 4. Well, my two-digit number is 4 Remember back here when we did that? Right here. My two-digit number is 10 times A plus B. Right there. So my two-digit number then is 10 times 4 plus B, which is 2. 10 times 4 is 40, plus 2 is 42. Now I can check that with the problem itself. Let's read the problem and look at the number 42 while we do it. Two-digit number, a two-digit number is equal to 7 times the sum of its digits. The sum of its digits is 4 plus 2, which is 6. 6 times 7 is 42. The two-digit number is equal to 7 times the sum of its digits. The number formed by reversing its digits, 24, is less than the original number by 18. Well, 42 minus 18 is 24. So it fits both of those criteria. I've written two equations that represent the number. I then simplified those equations to come up with these two equations. And then I used the process of elimination to solve those two equations for A and B to get my two-digit number. This is a much more complex way of looking at two linear equations and using them to solve for two variables. I didn't expect everybody to get 100% on this one. I expected everyone to try it, but I expected that it would be quite difficult as well. Most of the students that I have taught over the years haven't been able to get this one, but I love to give them that grapple. Cool?